This is Module 5, Lesson 13. In this lesson, we'll be using benchmarks to compare two fractions on the number line. Let's start with the fractions 7/8 and 6/4. And we want to compare these to see which one is greater. Looking at the denominators, we see that this is eighth and this is fourths. The numerators tell us that there's 7/8, so this fraction we know is less than 1, since 8/8 would be 1. On the other hand, 6/4 would be greater than 1, since 4/4 is 1, so 6/4 would be greater than 1. So right away we can see that 7/8 would have to be less than 6/4. We can further look at the fact that we can decompose 6/4 into 4/4 and 2/4. 4/4 being equal to 1 and 2/4 is also equal to 1/2. So 7/8 is less than 1 and 6/4 is equal to 1.5. So let's show those on a number line. This time, since one of our fractions is greater than 1, our number line is going to have to extend to the number 2. We won't be able to plot both of them between 0 and 1. So 8/8 is 1, so 7/8 would be a little bit less than 1. And 6/4 would be halfway between 1 and 2. So since it's equal to 1.5, so this would be where we would plot 6/4. And we could see that that shows us that 7/8 comes before 6/4 on the number line. So 7/8 is less than 6/4. Let's look at two more fractions. 5/3 and 9/5. Well, this one's a little more difficult because we can see right away that both of these are greater than 1. Because in both situations, the number of pieces the whole is divided into is less than the total number of pieces. So here we can see that this would be 3/3 plus 2/3, where 3/3 is 1. So this would be equal to 1 and 2/3. This one could be decomposed into 5/5 plus 4/5, which would be 1 and 4/5. So since each of these fractions have one whole, what we're really comparing is the fractional part that would come between 1 and 2. So let's draw a number line. And we know both of the fractions are going to fall between 1 and 2. And we're going to take what we've learned about comparing these two fractions, 2/3 and 4/5, and think of the space between here and here. Where would 2/3 and 4/5 be? Well, we know 2/3 would be around here. 4/5 would be almost another whole, so it'd be closer to here. So if we plot these, remembering that 1 and 2/3 started as 3/5 and 1 and 4/5 started as 9/5, on our number line we'd plot this as 5/3 and 9/5. Therefore, 5/3 is less than 9/5. Let's look at another one. Let's start with the fraction 11/8. Well, we can see that this is greater than 1 because this would be equal to 8/8 plus 3/8. And let's compare that to 1.5, another benchmark fraction for us. Well, we know that this would also be equal to 1 3/8 since 8/8 is equal to 1. So this would be 1 3/8. And we know that 1 1/2 is equal to 1 4/8. So if our fractional parts are divided into the same number of equal sized pieces, if we have 3 pieces, we have less than if we have 4 pieces. Therefore, 1 3/8 would be less than 1 4/8, or 11/8 is less than 1 1/2. If we plot this on our number line, we'd see that 1 1/2 would be right between 1 and 2. And 11/8, since that's equal to 1 3/8, would be a little bit less than that and would be plotted there. Let's look at another point, another fraction. Let's look at 5/4. Again, we could decompose this into 4/4 plus 1/4, or 1 1/4. So if we put that on our number line, if this is 1 and this is 1 1/2, we know that 1 1/4 would be in between the two, halfway between 1 and 1 1/2. So 5/4 would come here. And now we can write a statement comparing these two fractions, that 5/4 is less than 11/8. And both of them are less than 1 1/2. Looking at one more. Let's look at these two fractions, 14/10 and 7/5. Now we can see right away that these are both greater than 1. But we also notice that 10 and 5 have a relationship that's similar to 14 and 7. If we divide 10 by 2, we get 5. And if we divide 14 by 2, we get 7. So that would tell us that 10/14 is actually equal to 7/5. They're equivalent fractions. That's always a good place to start when we're looking to compare, is see whether or not we can turn these into fractions that have the same denominator or the same number of pieces. Then they're easy to compare. So let's do that. Let's say 14/10, and if we take 7/5 and we multiply each of them, we see that we have 14/10. So we can either compose by dividing or decompose by multiplying and see that these two fractions are equivalent. Let's look at 6/4 and 11/10. If we decompose this, we get 1 2/4, which is equivalent to 1 1/2. And if we decompose this, we get 1 1/10. And since the ones are the same, we're comparing these two. And if we have one piece where the whole is divided in half versus one piece where the whole is divided in 10 pieces, this is a much larger piece than this is. So therefore, 1/2 would have to be greater than 1 1/10. Let's do some problem set problems. So for 1, it says to place the following fractions on the number line given. So pause the video and take a minute to do that. Okay, first of all, let's look at these fractions and get a better idea of what they are. 4/3 would be 1 and 1/3. So if we look, we're going to see that that is going to fall between 1 and 1 1/2. It's a little bit less. So we're going to say about here and mark that as 4/3. The next one would be equal to 6/6 plus 5/6, which would give us 1 and 5/6. If it was 1 and 6/6, we'd have a second whole, and it would actually be 2. So 1 and 5/6 is going to be just a little bit less than 2. So 11/6 is a little less than 2. For C, 17/12 would be 12/12 plus 5/12. And we know that 6/12 is equal to a half. So it would be 1 and a little bit less than a half. Since 6/12 would be half, 1 and 5/12 would be about here. So that would be 17/12. So we've reasoned out the location of our 3 fractions. Then based on that, we're writing this as 1 and 1/3. This is 1 and 5/12. And this is 1 and 5/6. Then pause the video and do number 2, A and B. So based on this, we see the largest of the 3 fractions is 1 and 5/6. So 1 and 5/6 is greater than 1 and 5/12. Its location is here, making it greater than this one. And for B, 1 and 1/3 we see is a smaller fraction, so it's less than 1 and 5/12. Okay, using the same strategies, pause the video and try and place 3, A, B, and C. Okay, this fraction would be 8/8 plus 3/8. That would be 1 and 3/8. We know 1 and 4/8 is a half, and this is 1 and 1/4. So it's going to be, which would be 1 and 2/8. So it's going to be right here between 1 and 2/8 and 1 and 4/8. So this would be 11/8. For the second one, we have 4/4 plus 3/4. So that's 1 and 3/4. So here we have 1/2, and here we have 2. So if we divide the half in half, this would be fourths. So this would be 1 and 3/4. So 7/4 falls right here. And finally, this would be 12/12 plus 3/12, which would be 1 and 3/12. And if we simplify this by dividing both the numerator and the denominator by 3, we get 1 and 1/4. And we have that point marked here. This would be 1 and 1/4, halfway between 1 and 1 1/2. So 15/12 falls right here. Pause the video and use the number line to answer 4. Okay, the reasoning is that 11/8 is equal to 1 and 3/8, which is less than 1 and 4/8 or 1 and 1/2. And 15/12 equals 1 and 1/4, which is equal to 1 and 2/8, which is less than one and 3/8. Okay, moving on. For 5, we're going to be comparing the 2 fractions, writing greater than, less than on the lines, and then give a brief explanation for each one. So pause the video and try A. Okay. For here, 3/8, if we compare to the benchmark of 1/2, 1/2 equals 4/8, and 1/2 equals 6/12. So 3/8 is less than a half, And 7/12 is more than 1/2. So 7/12 has to be greater than 3/8. So 3/8 is less than 7/12. Try B. Okay, for B, 5/12 is less than 1/2, since 1/2 would be 6/12, and 7/8 is more than 1/2. In fact, it's almost 1, so 7/8 would have to be larger. So 5/12 is less than 7/8. Try C. For C, we see that 6 is a factor of 12. So we could just change this fraction into 12ths by multiplying by 2, and we get 16/12. And since these are both 12ths now, it's easy to see that 16/12 is greater than 11/12. Try D. Again, we see we have denominators that are factors of each other. So 3 is a factor of 12. So we could multiply 1/3 by 4 to get 12ths, and we'd have 4/12. And we compare 4/12 to 5/12. We see that 4/12 or 1/3 would be less. So, 4/12 is less. So 5/12 is greater than 1/3, which is equal to 4/12. Try E. So for E, 7/5. Again, 5 is a factor of 10, so we could easily multiply by 2 and get 14/10, and compare that to 11/10 and see that 14/10 is greater than 11/10. So 7/5 is greater than 11/10. For F, again, we see 4 is a factor of 8, so we could easily multiply the numerator and the denominator by 2 to get 8s, and we get 10/8. So we can see that 10/8 is greater than 7/8. Try G. Okay, for G, 12 and 10 are not factors of each other, so let's use our reasoning with the number line. So 13/12 would be equal to 1 1/12, whereas 9/10 is less than 1. Since it would have to be 10/10 to be equal to 1, so 1 1/12 is going to be greater than 9/10, so 13/12 is greater than 9/10. Try H. Here right away, before doing anything, we can see that 6/8 is less than 1. Whereas 5/4 is greater than 1. So 6/8 has to be less than 5/4. For the next one, we have 8/12 and 8/4. And again, we see the numerators are the same. So I have 8 pieces of something that's divided into 12 pieces versus 8 pieces of something that's divided into 4 pieces. So these are going to be much larger pieces. So if I have 8 of these pieces and 8 of these pieces, this would have to be greater. Also, 8/4 is equal to 2. 4/4 plus 4/4 would be equal to 2, whereas 8/12 is less than 1. So that's another logic as to why 8/12 is less than 8/4. And pause the video and try the last one. For this one, we can use our strategy that 5 is a factor of 10. So if we multiply both the numerator and denominator by 10, we get 14/10. 14 tenths is less than 16 tenths. Therefore, 7/5 has to be less than 16 tenths. And that concludes lesson 13.